Today we're going to look at expanding and factorising algebraic expressions. In order to do this, we need to consider the distributive law. So the distributive law says that a bracket b plus c is the same as a times b plus a plus c. In order to do that, we multiply a by every term inside the brackets. When it's written like this, that is called the factorised form because the common factor of a has been removed and placed out the front separately. When it's written like this, that's called the expanded form because a is written twice. Sometimes the factorised form is useful, sometimes the expanded form is useful. So you need to be very competent at moving between the two. When we talk about expanding expressions, so going from the factorised form to the expanded form, we sometimes call that rainbow expansion because we end up with a little rainbow drawing. The x in plus 4 inside the brackets, usually if we followed the normal order of operations, bomb dash rules, we would have to do the brackets first. The issue here is that because x is a variable, we can't do x plus 4. Unless we know what x is and we substitute in and try and solve, we can't do anything with x plus 4. So we can't get rid of those brackets by adding x to 4. What if we use the distributive law, however? It tells us how we can deal with the brackets and turn it into the expanded form. Remember, there's an imaginary multiply in between the 2 and the brackets. So what this actually means is that everything in the brackets needs to be multiplied by the 2. So we can write that as 2 times x plus 2 times 4. That's now expanded. We then can gather like terms and simplify. So we would then write that as 2x plus 8. So 2x plus 8 is the same as 2 bracket x plus 4 close brackets because of the distributive law. We can demonstrate this if we substitute something in for x. For example, let x equal 5. If we substitute that in up here into the factorised version, we would get 2 bracket 5 plus 4 close bracket. 5 plus 4 is 9, so we now have 2 times 9, and 2 times 9 equals 18. If the distributive law is true, then we should get the same answer when we start with the expanded form. So if we take 2x plus 8 and we substitute 5 for x, we would then deal with the multiplication first here. So that would be 10 plus 8, and 10 plus 8 is 18. And because those two are the same, that then shows us that the distributive law is true. In this example, we're going to see what the effect of having a negative number has on the expansion. We still follow the same rules and we're still going to make our little rainbow picture as we go along. So in order to expand this, we would do 3 times a, and then we would do 3 times negative 5. It's important to remember in this instance that that minus sign is attached to the 5. That is one whole term, and there's an imaginary positive in front of the a. It's not 3 times 5, it's 3 times negative 5, which is very different. So 3 times negative 5 is the sum that we need to do. So 3 times a will be 3a, and 3 times negative 5 will be minus 15. 3a minus 15. Again, to check that, we can say let a equal 2. So if we go back up to our original, 3a minus 3 bracket a minus 5, if we substitute in 2, we will get 3 with 2 minus 5. So we need to do within the brackets first. So 2 minus 5 is negative 3. 3 times negative 3 will be negative 9. If we come to our expanded form, we have 3a minus 15. We said that a was 2, so if we had 3 times 2 minus 15, that will give us 6 minus 15, which is negative 9. So both of those are equal, which again shows us that the distributive law is true. Again, we can see the distributive law in effect even if we have much more in between the brackets than we did in the earlier examples. The distributive law holds true no matter how many terms are between the brackets, and this is where you can start to see where we get the name, the nickname of rainbow expansion. In order to go through all of this, we'll do it for each term, remembering that the sign is attached to the term that comes after it. There's an assumed multiply there, and that a is positive because that's assumed. We then end up with 5a plus 5 times positive 7, 5 times negative b, 5 times positive 2c. What we could then do is gather any like terms, and we don't have any like terms because we've got a constant and then we've got a, b and c. That's the expanded version, and you can see that this is where the rainbow term sort of comes in. Don't be afraid to actually draw those lines as you're doing it to keep track of where you're up to. We follow a similar pattern, again when the negative sign is out the front. Remember, that's attached to that x, so we follow the same rule of the distributive law. We follow that rainbow expansion. That's the 3 operations that we will need to do. Remember, there's an imaginary multiply there. So we'll get negative x times 7x will be negative 7x squared plus negative xy negative x times negative 4 will be positive 4x. That's the expanded version of that expression. The rainbow rule also applies when we have 2 sets of brackets, and we simply do exactly the same rainbows as before, first with the x and then with the y. So we have 7x plus x squared minus 2xy, and then we deal with the second one, plus 7y plus xy minus 2y squared. Then we need to go back and gather like terms. We've got an x here, we've got x squared, we've got xy, we've got y, we've got another xy, and we've got y squared. So the only thing we can gather there is the xy's. So if we have minus 2xy plus 1xy, that will give us minus 1xy. 7x plus x squared minus 1xy plus 7y minus 2y squared. So the rainbow rule can apply several times.